also know that senior class students are sitting over here, right? So, all right. So, good morning, everyone. My name is Randeep. Along with me, we have Garvit sir and Deepak sir, and we are from STEM and Space, and we welcome you all today to a very fun and exciting session on something that is very much an integral part of our entire world right now. And that is about something which you also might have heard. So have you heard about something called JWST? Have you heard about JWST? Anybody, anywhere in news articles or anywhere? Have you heard about this word? JWST. So it stands for James Webb Space Telescope. So when you think about telescope, have you heard the word telescope? All of you? Anybody who doesn't know what is a telescope? All of you have heard about it, right? So what is a space telescope then? All of you know telescope. So what is a space telescope? Am I audible to everyone at the back? I am audible, right? So 95 Alright, thank you. So what is a space telescope? It's very simple. There's no difficult definition to this. It's a telescope in space. That is why name is Space Telescope, right? So all of us, we are here to have a nice session on space science, astronomy, right? All of you are aware about that? And you have very beautiful skies over here, right? So in northeastern part of our country over here, you all are able to see very nice, beautiful skies every night. I'm sure sometime or the other, you all must have gone to your rooftops or gone to your house gardens and had a night of sleep over here. Do you all watch the night sky? All of you are staying over here, right? All of you are staying over here in this portion itself, right? So has anybody watched the night sky ever? Yes? So what do you watch in the night sky? Stars. Only stars. Moon also. Okay. Or what else? Some are saying what else is there? Moon and star is the only thing visible, right? But do you think all those twinkling objects are stars? What else is present over there? Planets, right. So planets are also present. Anything else? Yes? Universe, entire universe. So you're able to see the entire universe in your night sky. But you're able to see some portion of that universe, right? And when you said planets, right? Planets are also present. Okay. And when you try to learn more about these things, what do? You search it up on internet, you watch pictures, videos and all these stuff, right? And when you look at those pictures and videos, all those very high definition pictures and videos, who do you think actually took those pictures? You must have seen very beautiful galaxies, very beautiful planets, very beautiful stars, right? You must have seen pictures, videos, in movies and stuff also. So is there any photographer that we are having who is going out into the space, staying there for a couple of nights and then taking those pictures? What do you think? Does that happen? So whenever you Google up these things, you see these amazing pictures of galaxies, you see planets, you see people at the back. Is the screen visible to all of you? Okay. So all these, fine, very beautiful pictures, very beautiful videos that you see. So there is no human being who is going and clicking the photos, right? So how are these photos getting clicked? Satellites, that is true. So satellites have something that is actually clicking. Is it only particularly satellite or any specific kind of satellite? Satellite is a very good term that most of you have used. What is a satellite, by the way? What does satellite actually mean? No answer. Everybody said satellite. What happened? Yes, anybody? This is not your typical classroom session. You can give me any answers. It's completely fine. What is a satellite? Come on, senior class students, you all should know what is a satellite. No answers? Anybody? Yeah, don't be shy. It's time to flaunt your skills if you know before your entire school and class. मैंने एक सेशन में बहुत मस्त आंसर दिया था. No ideas? Okay, we'll come back to that. So there are certain special kind of satellites, right, that are responsible for clicking these pictures. So those satellites, that means objects which actually move around something. Can you give me an example of a satellite? Moon, very good. So I've got a very good answer actually. Directly moon. So why is moon a satellite? Why do we call it a satellite? Now you are coming to that point because it orbits the Earth only, right? Is it orbiting the sun? No. Earth के around घूमेगा लेकिन sun के around नहीं. It is of course revolving around the sun also, right? Along with us, because we are revolving around the sun. But yeah, so together the moon and the earth are revolving around the sun. But with respect to the earth, it is moving around the earth itself, right? So that is why we have classified it as a satellite. So if moon is a satellite, then what are these telescopes? Yes, space. Yeah, what are these space telescopes? So these are also similar to satellites because these also revolve around the earth. When we send them outside our earth, these also revolve around the earth, and these are specific kind of satellites which are just meant to click very beautiful pictures that you often see when you are looking at the internet, right? So that's what is the purpose of a telescope, a space telescope. So can you tell me then what is a telescope before going to space? You all said you all are acquainted with telescopes, right? I also found a few of you who were just down there and working out. Is there anybody here who was watching the sun with a telescope over here? Or have you ever worked with a telescope? Have you seen a telescope? You all have seen a telescope, right? Somewhere or the other it might have been kept or anything. You all have seen a telescope, right? It's a tube-like kind of structure. So this is what something looks like. So what is basically a telescope? So telescope is basically an optical instrument that helps us to see things which are very far away from us. It makes them appear close to us, right? So if let's say there's the moon, which is very far away from us, right? So through the telescope it will appear even bigger. Means it will appear nearer to us. That is the purpose of a telescope. Now moon is something which we are often able to see, right? Every night. What about the stars, the planets which are very far away from us? We are not able to see them. But when you Google it up, you are able to see very nice pictures. Leave off planets in other galaxies. Just think about the planets in our own solar system. How many planets do we have in our own solar system? 8. Okay. Which is the largest planet? Jupiter in our solar system. So even if you try to observe Jupiter in the night sky, will you be able to see that beautiful picture of Jupiter through your naked eyes? No, right? Yes, please saying yes. Telescopes है, okay. आँखों में telescope नहीं लगा ना? Okay, all right. So you are able to see the Jupiter when you are using a telescope, but that is the right answer that he gave. With the help of the telescope, you will be able to spot out that very nice, that very beautiful picture, right? And you will be able to even spot out moons of Jupiter and many other things. So what does the telescope actually have that is making it so special, that is making it possible to take up, these far away objects and make it appear bigger and magnified? So this telescope has certain amounts of parts. Okay, it actually contains something called as lens and mirror. Have you all heard about these two words? Mirrors, everybody knows mirrors. Everybody knows lenses. People wearing spectacles are often aware of that, but people who are not wearing, you also must be aware of that, right? So by now I believe that you all have already studied about lenses, mirrors, ray diagram and all those things. Physics में कहीं नहीं, right? So basically telescope, what it does is that it contains an arrangement, a very specific kind of arrangement of these two instruments called lenses and mirrors. So what it happens, it's basically a very simple instrument. Okay, it does it require electricity? What do you think? Does it require electricity to function? No, it doesn't. Do your spectacles require electricity? No, of course not, right? So telescope also, it is not a complicated instrument which requires electricity and all these things. It's a very simple instrument. What it does is that it has this mirror at the bottom. This mirror is called as the primary mirror. Okay, now we are not going into detail what kind of mirror it is. You must have heard about convex mirrors, concave mirrors. Ring the bell? Okay, all these things are there. Not only front benches, back benches also. You probably will be the front bencher in your class. Okay. So people at the back. So you all have heard about lenses and mirrors and different types also. Okay. So what happens is that usually there is a concave mirror which collects all the light that is coming from the stars, the galaxies, whichever are there very far away from us. All that light, when it enters through this tube, it hits the mirror. And what will the mirror do to that light? Reflect. Very good. So it will reflect that light, right? Wherever it reflects, but it will reflect that light. And all that light will get reflected into another point. If you are aware, then concave mirror is a type of mirror which actually reflects the light in such a way that they meet at a particular point. Remember, focus point, focal length and all these things. You must have read this or learned this, right? In your classes. So what happens is that all these rays actually come to this point where we simply place a plane mirror, the simple mirror, which you are looking at it every day while combing your hair, while looking at your face, right? So what we do is that we simply place a plane mirror, which we call as a secondary mirror, and all that light rays will get reflected again from the plane mirror, but we place it in such a way that it gets reflected towards the outside. That means it will go out of the tube. And what we do right over here? What will happen when the light gets reflected over here? We can see the image. So we place our eyes over here, and what we do is that we usually put a small lens also at the end so that the image appears even bigger. Because lens usually what it does. Have you seen magnifying glass? Yes. Okay. What will magnifying glass do? It will enlarge the image, right? It will make it big. So what happens is that all the light rays, it comes over here and the image appears even bigger and closer due to this telescope. This is basically how a telescope works. Even if the design changes, even if the look changes, even if the materials change, the basic principle remains the same. So this is how telescope. So everybody clear that how the telescope works? Okay. Only yes, people others didn't understand how the telescope works. Everybody understood, it's very simple. Yes? Very good. Thank you so much. Okay. But now that you understand that what is a telescope, the question still remains, what is the need of a space telescope? Let's say I have a nice big telescope. You all have seen also telescopes here and there, okay? And you have a very beautiful night sky over here, right? Often there is almost no pollution. Once you go a few kilometers away, you have completely dark skies, right? In the cities, we usually have, if you go to Guwahati city or if you go to any other city, you'll have a lot of, lights and all these things, so you may not be able to see the night sky. So that is also one of the reasons that why we usually take the telescopes to dark places. Have you ever seen anybody using a telescope where there is a lot of light? No, right? Usually they carry the telescopes to very dark places, isn't it? They come to these dark places, they go to these lands and then they try to click the pictures. They go to mountains and all these stuff. So why do they do that? Any ideas? Why do they do that? Why do you need to go to dark places with your telescope? Yes? Light can burn the lens. That is what he is saying, true or false? How many are agreeing with the fact that light can actually burn the lens? How many are not agreeing? That means everybody is not agreeing. But I agree with what he said. Yes. You are also agreeing? Because he is your friend? Oh, no. Oh, okay, alright. Because he is right. He said no in a way that he doesn't want him to be his friend. Okay, alright. So, what he said is actually true during the day. Because during the day, we usually point our telescope towards the sun, it will actually burn out. Okay, that is why you must have seen that there is some kind of filters also which are used on the telescope. Well, we are not going into that. So one of the reasons why we need to take the telescope out into the dark is light pollution. Have you heard of light pollution? Pollution due to light. Light can also cause pollution. You must have heard about air pollution, water pollution, soil pollution. You may have given essays, all these things, right? But there is also something called light pollution. Okay. And light pollution is something which is actually a pollution problem for astronomers, for space enthusiasts like us. Because if you want to look at the universe using this telescope, then light can create a big obstruction. Okay, if we go to dark places, we are able to see all those stars, all those planets, all those beautiful objects that are there in the sky, right? But if we are having a lot of light, we won't be able to actually see those things. So light pollution is the reason. But even if we have gone to a dark location, let's say we are able to see the things very nicely, there is another problem that still exists on our Earth. There is another problem for our telescopes. Even if I spent crores of rupees and I built a very nice big telescope, but I have placed it on the Earth. Somewhere very dark, but I have placed it. But there is still another problem. Can you look at the picture and guess that what is the other problem which we have on our Earth? What kind of hint are you getting by looking at this picture? What is this? Layer, yes, what layer? Atmosphere. Here, atmosphere, so whatever. So, atmosphere, right? So, that is actually a problem. While we are able to sustain our life only because of the atmosphere, but for astronomers, that actually is a big problem. Why is that a big problem? Because whenever light is coming from all those distant stars, galaxies, whatever is there, and leave all those galaxies, even from the moon, even from our planets like Mars, Jupiter, and stuff, whenever the light comes, due to this atmosphere, what does the atmosphere contain? Air, yes. What else? What is there in that air? Be more specific. Yes. Ozone layer also. Yes. Certain gases are present. Dust is also present. Right? Some ions are present. Remember there is some layer called ionosphere also that is present. So due to all these factors, the light which is falling on the atmosphere, many of the light actually gets reflected back. And there is also some other amount of light that actually gets scattered because of this atmospheric layer, and some that gets actually absorbed. So tell me that if there is a light that is coming over here, if some part of that light is getting reflected, some part is getting scattered, some part is getting absorbed, will the entire amount of light be able to actually reach the ground? No, right? Because much portion of the light is actually getting lost in this particular way. Are you understanding what I am trying to say? If I am, let's say I am holding a torch over here, a very strong torch I am holding over here, will that entire light of the torch reach the earth? Because the atmosphere will actually cause much of the light of that torch to actually get reflected or absorbed or scattered. And that's why, since many of the light will actually get lost, we'll be able to get good quality pictures through that telescope. Because how is the telescope working? It is taking up all the rays of light, right? So if there are 100 rays of light, let's say, which are coming from space, will all those 100 reach the telescope if it is on the ground? Will it reach or not? All the 100 won't reach, right? Are you understanding what I am trying to say? All that 100 rays of light will not reach, because out of that 100, 10 may get reflected. There are 20 which may get scattered. So 30 are already lost. So 70 will only be absorbed and it will be able to actually reach. Out of that also 10, 20 will be actually absorbed by those gases. Understood? So if that happens, then ultimately you are getting only 50 rays of light that are actually reaching the ground. And that is the reason that we actually need to send the telescope to space. What happens if I send the telescope outside the Earth? Will it have any atmosphere to block its rays? No more atmosphere. Will it have any light pollution? No bulb glowing over there? Or is there any bulb glowing in space? No bulb? Is there any problem of light pollution that still exists in space? No? You don't think so? There is this huge bulb which is glowing out in space. It is bigger than all the bulbs that we have, bigger than all the LEDs. So first we are trying to escape into dark locations, and then we are sending a telescope to space where there is infinite amount of sun. So then what is the point? We solved the problem of atmosphere, that okay, we are sending our telescope to space. We are building a nice rocket and we are just launching it. Now it has gone to space. No atmosphere problem, very nice. What about the light? Light pollution है because you have the entire sunlight. So that is a big problem, right? So there is some way in which we need to solve that problem, right? We need to solve that problem. if we are taking it into the space, we are solving the atmosphere problem, we also need to solve the sun's problem, right? So that is actually one of the problems which scientists started facing when they thought that we'll send telescope to space. That means we'll actually build space telescopes. So we'll see that how scientists are actually able to solve that problem. So did you all understand why do we actually need a space telescope? Why we actually spend billions of dollars, spend 10, 20, 30 years to build telescopes that we are able to send out of the Earth. Is that clear to everyone? What is the need of space telescope? So since it can collect many different kinds of light, it can give us clear, sharp images. Now there is a line which has been written in red color. Can collect many kinds of light. What is the meaning of many kinds of light? Light also has kinds, types. Does light have types? What do you think? Has anybody seen this kind of picture ever in their life? Or you have heard about any of these words which are written on the screen? For people sitting at the back, there is a very big electromagnetic spectrum written on it. And then you have certain radio waves, then you have infrared, you have X-rays, ultraviolet, gamma rays. Have you all heard of these? Have you just heard of these? It's fine if you don't know the meaning. Have you heard of these words? Any of these words? X-rays, gamma rays, UV. You must have heard, right? That we are even protected from the UV radiation of the sun and all these things, right? So these are actually also different kinds of light. That is why you might remember in your science lessons you often write as UV light. You write UV and then you write light also. Remember? So you write UV light. That means UV is a type of light. That is why we are using light word. So similar to that, just like UV, there are some other types of light as well, that is such as infrared, radio waves, X-rays, gamma rays and so on. And can you see this small portion in this entire spectrum? Don't get carried away by this word spectrum, it simply means range. Okay, so just consider it as range. In this entire range, can you see this small portion which has all the different colors? You can see violet, indigo, blue, green, yellow, orange, red. कुछ आया दिमाग में? What? Vibgya, rainbow colors. All our colors in this entire universe are being made by mixing of these colors only. So that means all that we are able to see through our eyes, everything, right from this floor, from this marble, till the sun, the moon, the planets, whatever we are able to see, all of them, for us, they are visible in this range only. We are able to see only this portion. In this entire range, our eyes can see only this portion. That is why we are able to see these colors. Have you ever seen UV light in your life? You know that UV light is present through sunscreen and all these things. We wear sunglasses also. Okay. But have you seen UV light? That UV light is coming from the sun. Okay, let's move aside here the UV will not come. Does it happen like that? Has anybody undergone X-ray ever? Like you had a fracture in your arm or leg. Have you gone to an X-ray? You see you are put into a machine. Or leave of X-rays. You must have gone to malls, you must have gone to airports, anywhere where you see this big scanner through which the security personnel asks you to walk through. Have you seen that? There's a very big door-like structure. You walk through that, and if you have any metal objects, it will like something like that, or the light will start glowing. So all these are actually different kinds of light. That's those scanners that you see. Or you must have seen even security personnel having this magnifying glass structure. Start scanning like this. पूरे हाथ पैर में scan करते रहते हैं. Have you seen that? That they often scan for different objects. If you have a gun, if you have a knife, if you have a metal object, so that they can detect if you have that, right? So how does it actually work? How is that machine able to know that if you have a knife hidden in your pocket? That should not be magic, right? There should be some science behind it. That science is nothing but X-rays. So X-ray is a kind of light that we cannot see, but that machine will be able to see X-ray. And if that machine is able to see, you must have heard about night vision goggles. In movies you may have seen night vision goggles. In the dark, suddenly your hero is able to see everything in the dark. Because he is using heat vision goggles. If you play games and stuff, you might know about that as well. Heat vision goggles, night vision goggles and all these things. So why through our naked eye I am not able to to see anything which is right in front of me, but by after wearing that goggle, I am actually able to spot out this boy who is sitting over here. So what is happening? That goggle is actually helping me to see this infrared. You all have TV in your homes? All of you have TV, but nowadays you must be having smart TVs. But some of you might have observed, if you had slightly older version of TV, then you have a remote at the top of which there is a small LED light which is actually placed on the top of that remote. Have you seen that remote? That TV remote? And that actually doesn't glow. वो light तो जलता है क्या? That light actually doesn't glow, right? But it actually glows. We are not able to actually see that light. So since we are not able to see that light is something which is actually in this particular range, that is the infrared range. That is why we are not able to see. So that means if we are able to see only this portion, which is actually called the visible portion, because it's visible to us, it is what is the visible spectrum or visible range. If only this portion is visible, then what will happen to the objects which are there in the universe? Will we be able to see anything which is present in this X-ray, in this infrared, in this radio wave? Will we be able to see that? Yes? Will we be able to see anything which is outside this visible range? No, right? Because we are able to see only the visible range. Okay, so this range which is present is actually the total range of the universe. But there is a big problem when we come to the universe. Okay, whenever you go more towards the red side, let's say you are going towards infrared, you are going towards radio waves, your light will turn on becoming more red. It will become redder. While if you move towards the UV, X-ray, gamma rays, then it will become more bluish, more violet. That means it will become, that is why the name ultraviolet is here. Why? Because there is already the violet and you are going towards more violet, so name ultraviolet. Is that clear? So, if you are going more towards this, then the light becomes more blue. That is why it is called blue shift. While if you go more towards this side, then your light will gradually become redder, and that is why it will be called as red shift. Did you understand blue shift and red shift? Now, another point which is very important is that your blue shift, as you move more towards the blue side, that means you have more energy. Have you heard of the word energy? Light is a form of energy, right? So since all these different light rays have energies, on this side the energy is higher, while on this side the energy is lower. So as you lose energy, as the light loses energy, everything loses energy, right? Do you have permanent amount of energy? If you take breakfast today, will you be able to walk for the entire year? Every day you need to have that breakfast, right? Every day you need to have food because energy will be, even if you are sleeping all day, still you are losing energy, right? So similarly, light also keeps losing energy, and eventually light, even if there is a blue light at some time, let's say today I have a blue light, eventually across millions of years it will eventually lose its energy and it will gradually become redder. So if there is a visible light, it will eventually become infrared. Did you understand? So light will get shifted towards the redder side, that means towards the redder colors, and that is called red shift. Okay. So let's quickly watch this video and understand that what is this redshift and how that infrared actually helps you to see things which is otherwise not visible. Just observe.
Although our eyes can see only visible light, we can build tools like infrared detecting cameras to see other forms of radiation. These tools are man-made eyes that view invisible radiation for us and transform it into pictures. Objects can emit all kinds of radiation. Observing the entirety of that radiation gives us a true picture of an object. When we turn these tools on space, they open up the entire cosmos to us in its full glory. When we look at the night sky, we see stars and planets, galaxies and nebulae in the form of visible light. But if we could see in infrared light, the sky would appear very different. For one thing, infrared light's long wavelengths penetrate clouds of gas and dust. The shorter wavelengths of visible light are stopped and scattered as they bite through collections of particles. So by detecting infrared light, we can see through clouds of gas and dust to warm objects inside, like just forming stars.
So did you all see the difference, what you can see through infrared compared to what we can see? Did you all see that? Understood? Okay, so next slide. So if you look at the difference that what we are able to see in infrared, so just understand that what a big difference it actually makes. We are able to see some things which is actually not visible to our eyes, right? So that is why, what if just instead of a normal telescope, we built a telescope that can see in infrared? Well, we cannot convert our eyes, right? Because that has been naturally given to us. Okay, but what we can do is that we can build something, we can build a telescope that can see in infrared. That can see things. You saw that there was a bear hiding behind the tree. Normally you are not able to see, but with the help of those heat vision goggles that are able to see in infrared, you are able to spot the bear. Similarly, there might be a galaxy behind which there is a star. Through our eyes, we are able to spot the galaxy, but we are not able to spot the star. But if you look through infrared, you will be able to spot the star behind that galaxy. Understood? What is the need for that infrared? So that is why we built this mighty telescope called the JWST. What was the full form of this JWST? In the beginning it was there. James Webb Space Telescope. So where does this name come from? James Webb comes from one of the administrators of NASA. Everybody acquainted with the word NASA? NASA is what? Yeah, that is a full form, right? It's good that you all know the full form. That's nice. So NASA is the space agency of the USA, right? It is the US space agency. So this James Webb was a person who was actually an administrator of NASA far back in 1960s and 70s. He did a lot of nice missions at that time. So to commemorate him, they named the telescope after him, James Webb Space Telescope, and it was launched with the help of a rocket called the Ariane 5 rocket. It was the rocket from European Space Agency. It's a very nice, successful rocket, and it was launched on 25th of December in 2021. Very recently, just 4 years back, it was launched from South America. And after it was launched, then it took about 2 months to actually reach. Now, how big is this telescope? Well, just imagine it's as big as a normal tennis court. That means about 20 to 21 meters. That's how long it is. And how high? Well, it's as high as a 3-story building, about 15 meters. So 3 floors of a building, that's how high it is. And as big as a tennis court. There's the tennis court just behind you. That's how big this entire telescope is. Okay, so this is the next one. Yes. Any questions? Any doubts? Sharma? Okay, alright. Anything related to this? Okay, alright. So, James Webb Telescope, before James Webb Telescope, since James Webb is actually a telescope which is very famous and it has taken very nice pictures in the last 3 to 4 years. But before that, there was also another telescope whose name you might have heard, and its name is Hubble Space Telescope. Have you heard of it? Ever? Anywhere written or anything? If you just Google up these beautiful images, you will often see there's Hubble written below or above it here and there. That means that image was taken by Hubble. So before this James Webb, Hubble was actually one of the most advanced telescopes that we had actually built. So when we built James Webb, it became even more powerful than the Hubble Space Telescope. And why it was more powerful? First is because of the primary mirror. Everybody remembers the primary mirror that we were talking about? Telescope. At the bottom there is a mirror, that is a primary mirror. So it doesn't matter whether it's at the bottom, it's at the top side, there is a primary mirror. That means the mirror that collects all the light. So the mirror that will collect all the light, if it is the primary mirror, then what if it is bigger? If it's bigger, it will be able to collect more light, right? So in the case of Hubble, that mirror was just about 2.4 meters in diameter. But the Webb's mirror, the James Webb mirrors, was 6.5 meters. You can see how big it was compared to that Hubble. So if it is so big in size, it will be able to capture more light, isn't it? So that's why that was one reason why it was more advanced than the Hubble Space Telescope. And when you compare the James Webb with the Hubble, so you'll be able to understand that how more advanced it was. And there were many other factors why it made it more advanced. So just have a glimpse of how the James Webb looks like and how it was developed.
Use it to look back in time and this is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Webb is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.
So did you observe that how when you saw the telescope there was the big mirror that was shown? It was actually getting folded. Did you see that? It was actually having some parts, right? So we'll see that what are its parts. But before that, let's just quickly look at the objectives of this James Webb Space Telescope. What are the objectives of spending so much amount of money into building such a telescope? Well, some of it we already discussed in the beginning. Study early universe after the Big Bang. Remember that red shift? Remember that? So as the light becomes more redder as time goes by, what will happen? Light will become more red. Let's say everybody is aware of this thing called Big Bang. Have you ever heard of it? There was this huge explosion, the Big Bang, that began our universe. At least that's one of the theories, right? We believe that. So when that happened, how long back did that happen? Any idea? It's written right over here. 13.7 billion years. Billion means 9 zeros after this. That many years before, so almost 14 billion years ago, there was this Big Bang. So just imagine when the Big Bang happened, the first galaxies were forming, right? So what happens if the light which was produced this billions of years ago, whatever light was produced, what will happen when we try to look at that light now? What will have happened to that light? If so many billions of years have gone by, what will happen to that light? That light will eventually get shifted towards the redder wavelength. Remember redder colors. So even if there was blue light that was produced at that time, even if there was yellow light, that will eventually shift to the red colors. Okay. As time is passing by, the violet, the bluish, all the colors are eventually moving to redder portions. Why is that happening, by the way? Why is the color changing to red eventually in these billions of years? Yes? What happened? Probably you were saying the right answer. What did you say? Energy. Remember? Light is a form of energy. So as it loses energy, it will eventually turn into the redder wavelengths and it will eventually go to the infrared region. So to understand what happened in the universe during the early times, just after the Big Bang, what we need to do? We need to look into the infrared region. That is the reason why we developed this JWSP to actually look into the infrared. So what was the next objective? Yes, next one please, sir. So after the Big Bang, the universe continuously expanded, right? And as it expanded, the light gradually moved towards the infrared region. So that is why when we had Hubble, it could look into only this much portion of the spectrum. That means it was able to see all the visible light and some portion, very small portion of the infrared. But if billions of years have passed by, our light must have become even more infrared. And there is a term which is given to that that is called near infrared, mid infrared, within the spectrum also. So was Hubble able to look into these lights? Was Hubble able to see these lights? No, because Hubble was able to see only this much. So we developed James Webb, which was able to focus on all this, almost the entirety of this infrared vision. Understood? So if it is able to see this far, then it will be able to see exactly what happened when the Big Bang was happening, right after the Big Bang itself. So it is primarily looking at the infrared vision so that we are able to understand the early universe. If we are able to understand the early universe, we can eventually understand the evolution of galaxies also, that how the galaxies actually developed, right? So we are able to learn even that. We are also able to learn, next objective please. We are also able to learn about exoplanets. Have you heard of exoplanets? Anybody? Have you heard of exoplanets? No? Exoplanets are planets which are outside our solar system but has the potential of sustaining life. Probably they have some qualities like Earth, probably they have water, they have air, they have oxygen, so probably they will be able to sustain life. So these are exoplanets. By using the James Webb Telescope, we are actually able to detect exoplanets. And we could even observe the star and planet formation. Because remember, James Webb was able to see through those dust and gases, remember? It was able to see even things which are behind those dust, behind those gases, which are hidden behind also. So we are able to detect even the stars, even the planet formation, all the dust particles. Through the dust particles, we are able to see that. So these were the objectives because of which we actually built the JWSP. And then comes the engineering. How did we actually build this humongous thing? So this JWST, to achieve all these objectives, it actually required, first of all, you can see that it required a large mirror that can collect all that light from the distant objects, right? So how did we build this mirror? And next, it will also require powerful infrared detectors so that it can see through that dust. Because remember, we are trying to make a telescope which can see in infrared. So we need those detectors as well. Okay? So these were some of the engineering challenges. How to design a giant mirror, how to even take it to space, that was another problem. We built a telescope as big as this entire room and then we think that how to take it to space. How to keep the sensors cool from its own heat, because it will also generate some heat, right? Because it has certain computers, machines, and then there is also heat from the sun, remember? So that problem is also there. We are still not able to solve that problem. So that is still left out. And how to protect the sensors from that sunlight. So all these engineering challenges were there. So how did they solve it? Let's quickly look at one by one. If you look at the giant mirror, instead of that Hubble, where you saw that there was a round circular mirror, right? There was a single piece of mirror. What scientists did, they took 18 such small mirrors and joined them together to build this huge mirror. So this is something like a honeycomb structure. Have you seen honeycomb structure? Where can you find them? Where have you seen the honeycomb structure? In beehives, right? If you see honeybees, they build such kind of structures. So taking inspiration from that, they took 18 hexagonal mirror-shaped structures. But why only hexagon shape? What will happen if they took circular shape? Because even if they take circular mirror segments, let's say, if they join them, what will happen? A lot of gaps will be left out. Can you see this? If gaps are left out, much of my light will actually escape from these gaps, and I will lose a lot of light. And I don't want to lose light, otherwise my picture quality will reduce. So what if I use squares? Because if I use squares, there is no gap. But square in itself is a very problematic shape. First of all, it takes a lot of space, you can see. Here I had a lot of space left out. It actually takes a lot of space, and there are many other problems with the light also that will occur if I decide to take rectangular or square shape. So after the experiments, they finally concluded that let's take the hexagonal shape. If we join hexagonal shapes, then there are no gaps, you can see. There are no gaps at all if I join them properly, and it will be almost a round shape. It will not exactly be a circular shape, but almost a circular shape. Okay, so that is why they went with a hexagon shape. Okay, so all these hexagonal shapes joined together to form this roughly circular shape, which has a high filling factor. That means there are no gaps which are left out. Remember that. Okay. Now, what was the other problem that we are actually facing? If you look at this giant mirror, then what is the material that was used? Because we need to have some material which is strong, but at the same time it is not very heavy, right? Otherwise we won't be able to carry it in the rocket easily. So that is why they took this element called beryllium. Have you heard of beryllium? In your chemistry classes, you might have seen that this element is roaming here and there. Okay, you all study about hydrogen, oxygen, chlorine, fluorine, all these things. But you might think that where is this beryllium used? Well, they used this beryllium because it is strong, and at the same time, it actually has very light weight. Okay, and it can even remain stable at very low temperatures. Now, why is stability required? Is the temperature in space very low? What do you think is the temperature in space? In the regions where we are trying to send these telescopes? Yes, minus 273. What do you think? So yeah, it is that cold, not completely minus 273, but in the range of minus 220, minus 230, minus 240. That's how cold it is. So we need something that can remain stable even at those cold temperatures. So they took beryllium. But beryllium will not reflect the light properly. The mirror has to reflect, right? So you can see this very nice shiny coating which is present. What is this? So over the beryllium, what they did is that they have put gold, pure 24 karat gold. So what they did is that they took pure 24 karat gold and they slapped upon this so that they can form the layer itself. Okay, and that mirror was coated with gold so that reflection can occur properly, because gold will be able to reflect all the amount of light, it will not absorb anything. And remember that sunlight problem. If sunlight is there, how will we take pictures in the dark? Well, they built this huge tennis court shaped sun sheet made up of 5 layers. So it was big so that it can be protected from the light, and it had 5 multiple layers so that it can be protected from the heat of the sun. Because as the heat reaches the first layer, some of it will get absorbed, then it reaches the second layer, it will get further absorbed, then it reaches the third layer, it will get absorbed more, fourth layer. By the time the heat reaches the 5th layer, almost all the heat is gone. So they actually made 5 layered, multi-layered sun sheets so that it can help the telescope remain cool. And its own heat will not destroy the telescope. Okay, and this is the reason why it became so big in length. Remember how big it was? 20-21 meters the size of a tennis court, right? So, next one, please. So, if you look at this sun sheet, okay, so this is how it was actually made. Now, if you look at the entire structure, how did they fit into the rocket? That was the other problem. Well, they made it in such a way that it can be actually folded. So, the entire structure was foldable. Do you know about origami? Paper folding, origami. So, using principles of origami, they designed the materials in such a way that it can be folded and it can be fit into this rocket. And once it is fitted, it will be launched, and after launching, what will happen is that it will get eventually unfolded. So, just like it was folded, it will get unfolded. But the point is where? Space is huge. Entire thing is space. So, where to put? Well, that's where they thought that let's put this telescope in a very particular point called the Lagrange point. Have you heard about Lagrange point? So these are points. Have you heard about gravity?
Yes, sir.
Do you know that Earth has gravity? Even the Sun also has gravity. Every object will have its own gravity, right? So these Lagrange points called L points, these L points are points in space where the gravity of the Sun and the Earth get balanced. That means if you are at that point, neither the Sun will be able to pull it towards yourself, or neither will the Earth will be able to pull you towards yourself. Remember, so you will be balanced. So these points are, and there are 5 such points, L1, L2, L3, L4 and L5. Among them, L2 is the point which is actually away from the Sun. L1 is the point which is towards the Sun. So you might have heard a mission called Aditya L1 that was actually launched by ISRO. If you have not heard, just search it out when you go home. So that was placed in that L1 point because it actually needed to face the Sun so that it can take pictures of the Sun. But here we have to move away from the Sun, we have to remain away, so it was placed at the L2 point. And if it is at a place where there is minimum amount of gravity pulling it from the Earth and the Sun, it will require minimum amount of fuel also, right? So those were some of the advantages that was there while it was placed in the L2 point. Okay, so this is the reason why this Webb telescope was actually placed in the L2 point, which is at 1.5 billion kilometers away from the Earth. Okay, and it can remain cool, dark, as well as it can be stable, perfect for the infrared view. Next one, sir, please. So, did you all understand that why this JWST was actually placed in the L2 point? so that it can be completely away from the sun, and that massive sun shield can protect it from the sunlight and the heat as well. Okay. So now what we are going to do is that today we are going to make a model of this JWST. We are going to make our own JWST model. Okay, so I will quickly show you the parts. Meanwhile, sir will distribute the materials to all of you. Now you all have been asked to sit in groups so that you all can share the sellotapes that you can see on the tables. Okay, we'll give you the instruction whether to use sellotape or Fevicol during the activity, but it is for sharing the sellotapes. So you all can just turn your chairs, but make sure that you are able to see the screen as well, because I will show you the steps on the screen. Okay. So all of you, please take out the materials. When you take them out, you will find that there are 4 cutouts which are present. You have this first cutout, this hexagonal shape, and then you have this big shape structure, and you have 2 more cutouts. Now people just quickly observe the screens. Meanwhile, while you are getting the kits, just quickly observe the screen. That what were the different parts that we are actually going to make in this JWST. Well, first is the biggest part, that is the multi-layered sun shield. Okay. So you have a part, you can see that in your kits you have this grey colored part, which has yellow colored borders all around it. Right? The biggest part. That will act as your sun shield. Okay. So what we are going to do with the sun shield? So once all of you have got the kits, I will show you the video. People at the front over here, the first 4 or 5 tables over here, you can look at the screen. Okay, you can observe that how we are folding. People at the back, you probably won't be able to look at the screen. So we will show it to you over here itself, that how you need to actually fold each part. Okay? It's a very simple activity, but you need to follow the steps carefully so that you can make the model properly. So people just look at the first step what we are doing. Okay. People at the front, you can watch the video. For people at the back, I am coming. You can see instead of white dotted lines, you have green lines which are actually printed on this particular part. You can see very faint green lines. First step is to just fold along those green lines. Okay. You just need to fold along those green lines. On the screen it's written white dotted lines. Instead of the white, we have actually turned it into green. So just fold it towards the inside. That's it. That's the first step. Because after this we'll be making further folds, it will become easy for you. Just fold along the green line which is actually present. Okay? You can see this green line. So you need to just fold. You need to make the folds like this. That's it. You need to fold like this. And over here. That's it. You all see? Yeah. Don't keep it folded, just fold so that you can proceed with the next steps. People at the front, am I clear? And don't worry about the toothpicks that you are getting. You can keep it aside. We will use it at the end.
Look the video.
Yeah.
So all of you can see that you have a part which is labeled as 2. There are certain numbers written on your parts. Okay, so you can see that there is number 2 which is written. So fold those 2 parts which are labeled as 2. You can see 2 small flaps which are labeled as 2. Can you all see this? So you just need to fold that part number 2. That's it. There are 2 portions, one on either side. You just need to fold that part number 2. You also have a green line drawn over there, so you need to fold along that green line. Now after you have folded part number 2, you all can see that there are long parts which are labeled as 3. Part number 3. Can you see that? Now you need to fold parts number 3. You have 6 such parts which are labeled as 3. 4 long parts and 2 small parts. Can you see that? Yes, just fold it towards the inside. What happened? You are able to fold it. You can see that these parts are labeled as 3, right? So you just need to fold them towards the inside. Basically, all your yellow colored portions will be folded towards the inside. You can see all the yellow colored portions will be folded towards the inside. Whether they are labeled as 1, 2 or 3. Yes, people over here are able to follow. Just fold all the parts that are colored in yellow. Whether they are 1, 2 or 3, put all of them towards the inside. Okay, so people, after you have folded all these yellow portions, now we'll start pasting. Now you can see parts which are labeled as 1, right? So parts which are labeled as 1, what you need to do is that you need to put Fevicol, what glue you have, put glue on parts which are labeled as 1 and paste it towards the inside like this. Can you all see? This is how you need to paste it. Okay? Yes, good. Yes, people are over here at the front. Are you able to follow? You need to put glue on the flaps which are labeled as 1 and you need to paste them towards the inside like this. Okay? This is how you need to paste it. So you have 2 flaps which are labeled as 1. So paste both of them on the inside. paste both of them. When you paste parts number 1, you will start getting a diamond shaped structure, right? And people who are doing in each table, if you are able to do it properly, just help out your friends as well. So people now observe this video very carefully how you need to paste part number 2. Once you have pasted part number 1, you can see your part number 2 is a very small flap. Okay, so you need to put glue on this part number 2 and you need to paste it by putting it inside that diamond shaped part that you have just got. Again, you have flaps which are labeled as 2 on both ends, so just close both the ends with the help of glue. Yes, did you all understand how we are pasting part number 2? Part number 2 is if it's not clear, I will play the video once again for people who might have missed.
Start from 11:20 na? 11:15, 11:15 and ask him to come. Okay, sir.
Yes, it's part number 2 clear to everyone? It's very simple now. Since you have pasted parts number 2 and 1, you can guess that what we are going to do with part number 3. No, very good. You should not guess because it's different. It was a trick question. So people who have pasted parts number 1 and 2, now you can take out that big pink colored portion which you have, because we are going to paste that part. Okay? So people, for this part number 3, you can see you had those long flaps which are labeled as 3. Just fold them towards the inside, put glue on those parts and paste that pink part over those flaps number 3. Okay? Yes, very good. You can just shoot 2 minutes. See, this is how you need to paste your pink flap on the part number 3. Okay? This is how you need to do it. Is it visible to everyone? You can just have a look. Okay. Basically, we are taking the pink flap and we are pasting it on the yellow colored flaps. Putting glue on the yellow colored flaps and pasting it. And it will form a closed structure. And this will act as your sunshade. This is your multi-layered sunshade. Okay? Yes. So people, since you are using Fevicol, after pasting, if there is any portion which is not getting stuck properly, you can seal it with cellotape. So how many layers does this sunshade actually contain? Yes, how many layers will it have? 5 layers, right? So do remember that. It has 5 layers. So people, once you have pasted that pink colored flap, once your sunshade is complete, you can just set it aside for it to dry up. While it is drying up, people who have done that, you can now start working on the next part. What was the next big part in this JWSP? Yes, all of you can just see the screen for a minute. The next big part was your primary mirror, right? Which was made up of how many segments? only 18 segments. Remember, 18 hexagonal segments were combined to form the mirror. At the end, I will have a very fun and exciting quiz for all of you. So do remember the facts, otherwise you won't be able to answer. So people who have pasted the pink flap, just take out this portion, this curved part which has the primary mirror printed on it. Okay, now people at the front, you can just observe the screen for a minute. After that, you can continue your step. For the next step, what we are going to do, we are going to use this particular part. Okay, can you see this? This curved part containing the primary mirror. And what are we doing in this part? We are folding, you have a flap which is labeled as 4. Can you all see this? A yellow colored flap labeled as 4. Just fold that flap number 4 towards the inside. And then fold this portion like this. Yes. So all of you just have a look for a minute. See, you have this particular portion. I'm folding this flap number 4. And after that, I'm curving the flap number, this portion, so that I can paste it on this flap number 4. This is how it will be. Is it visible to all of you? कोई भी एक नहीं है इसलिए बताया बस इसको क्या है हम तो पता है This is the next step. हमारा है सबने बना दिया. Yes, people on this side. Have you understood what you need to do? This is how you need to paste it. You can see. You will fold flap number 4. And you need to put glue on the flap number 4 so that you can just fold and paste it like this. Here you can use sellotape also. Sellotape and Fevicol is there for your own convenience. If you find sellotape easy, use sellotape. If you find Fevicol easy, use Fevicol. Yes, is it clear what you need to do? See, this is how you need to fold it. Have this flap, just fold it towards the inside. Glue on the and then roll it like this is how you need to So people, once you have pasted this part on flap number 4, you have small triangular flaps. Can you see small yellow colored triangular flaps? You need to fold these triangular flaps towards the inside so that you can paste the circular portions on them. You have triangular flaps on both ends. So just fold them so that you can paste the flaps like this. You can see on the screen, the picture on the left shows you how it should look like. Yes. Yes, very good.
Hey, sit. Hello.
Okay, now do you remember that secondary mirror? That small mirror that I had told you in the beginning? That collects all that reflected light and then puts towards the eye. So after this step, we will be making the secondary mirror, which is actually very simple. So people, once you are done with this step, in this circular cone, what we are doing, we are putting the 3 toothpicks that we are given. So for the toothpicks, just put the broad portion inside and keep the pointy portion towards the outside. So on the left, you can see the picture how it will look like. You need to put 3 toothpicks in the 3 holes that are made for you, and then you can take a very small pea-sized clay. Okay, you all have received your clay. So you can take a small pea-sized clay. Must have seen pea, matar ke dane. So you need to just take a very small sized clay, because the secondary mirror is very small compared to the primary mirror. Right? And by using the 3 ends of these toothpick, you need to support that pea-sized clay. So you can see in the picture as well as in the video how your secondary mirror will look like after you have built it out. Now in the JWST, a very important part that is also required is the place where you need to put your computers, you need to put your instruments so that you can scan those images and they can actually send the images to us, right? Where is the telescope located? Can anybody tell me? Very good. Put a small amount of very small amount of clay. So there is a part called as the spacecraft bus. Now the spacecraft bus actually contains all your computers, all your machines that will actually scan the images and then send the images back to us on Earth. We also need the images back to our Earth, right? So to make that, and then you have the solar power array as well. You need solar panels to power up these computers, right? So solar panels are also present. So on your pink colored flap, you can see solar panels are already printed in blue color. So for making the communication module, you can take up this fourth part. So people just observe the screen for a minute. You all can see that you have another fourth part which is left, which has a big cross inside a circle which is drawn. So you need to fold this part, all the yellow portions together so that you can make a matchbox out of it. You need to make a matchbox kind of structure. The picture on the left shows you how it will look like once you have folded and pasted. Yes, very good. So, yeah. Now for this last part, again the process is same. You need to fold the yellow portions and you need to make a box out of it. Okay? Yes, people over there are getting ready. So can you all... First you need to fold this part of Very good. Now you need to make this portion into this box. This is the box. Yes, very good. This is the box. You need to hold that part of the box. That will form the box. After that, you have flaps of both sides. Just like a match. Once you have made that, see, this is how you need to place it. You have this white color rectangle, white color rectangle. Just match these. This is our way.
box you have a small one. You see that? So your whole electric will actually go into it. You can put the punching in. And then again you take a small amount of clay over here. In the picture you can see. See, you can insert the configuration of the point. So half of the electric can be inserted in the box, half can be outside. Finally, you have this case. So just observe, here again these objects. You have this portion on the top, your matchbox is sitting over here. And your primary mirror. You can see you have white colored box over here, white colored box over here. Okay, you need to match these two. Very carefully you need to place it like this. This way. But make sure that when you are placing it, your gauge, that means it's pointing strictly towards the Shannon space area. The box and primary mirror. In the mirror you can observe that you have this rectangular part. You can see this. So this will actually get matched with this top. On the top also you have this rectangle.